97% of the Earth's water is held in the oceans. The other 3% is fresh water, with just 30% of that being stored as drinkable groundwater. The population of Florida is currently 21.3 million and is projected to grow by 300,000 each year. An increasing population means an increased demand for drinking and irrigation water, making sustaining water resources ever more important. You are all probably familiar with how we have altered Florida's hydrology, correct? We drain the land by creating an extensive canal system to expand our infrastructure and farmlands. We quickly realized the issues this caused as it lowered groundwater levels drastically, leading to saltwater intrusion, ruining some of our biggest drinking water supplies. We learned after that we need to create some kind of system to keep freshwater inland and saltwater out. We did this with canal gates that open and close to maintain targeted canal levels throughout the year. These canals now provide us with flood protection, recreation, and irrigation. However, what implications do these structures have on Florida's hydrology? I would like to direct your attention to the Three Gorges Dam in China. The creation of this dam has had a visible impact on the natural hydrology of the surrounding environment, indicated by the large pool of water upstream. But what if the impact is greater than what you just see here? What if it is impacting the water in the subsurface as well? Studies have shown surface water in streams, lakes, and canals have a direct connection to our groundwater. This connection, which is driven by water levels, runs from a high to low elevation. In Florida, this connection is prominent due to our porous limestone and sandstone geology. For example, if canal levels are maintained too low, water from the ground fills up into the canal. If the canal is too high, canal water is lost to the ground. This connection has environmental and hydrological implications. Loss of groundwater exacerbates the risk of shortages in our drinking water supplies, which can lead to land subsidence, sinkholes, and saltwater intrusion. There is also a risk that contamination from canals will run into our groundwater that we rely on for drinking. The focus of my research is to study how a flow control structure influences this important surface to groundwater exchange. To do this, I will use stable water isotopes to view the subsurface. You see, water has its own unique fingerprint. We can use this isotope data to trace the water movement throughout the water cycle and then derive the original source. I will use isotopes to track the movement of the water around the structure, determine the direction of exchange, and then quantify the water exchange between the two systems. The results from this study will help to answer such questions as, is flooding more likely to occur in highways and residential areas near a dam? Are nearby wells facing an increased risk of contamination from canal water seepage? These are all questions asked during legal disputes over the management of canals and rivers. However, due to a knowledge gap, cannot be fully answered. These results will aid in the management of canals and flow control structures into the future.